Hi there everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be learning about the life cycle of a star for GCSE Physics students. I hope you guys find this helpful. If you do, let me know, and if you are interested in space in any way, you have questions, let's get a discussion going down in the comments section. I always love to hear from you guys, and especially when there's topics to do with space. I think a lot of people often are very curious with this topic. So one of the questions I always get asked in the classroom is, what would happen if you fell into a black hole? And then the class starts to go from there. We have loads of questions afterwards. So this often takes a long time for me to teach this topic, but I don't mind because curiosity is the whole purpose of teaching science. So definitely, if you have any questions or you want to share a cool fact, let me know in the comment sections, and I will also put some information in the description box for you guys if you want to go and read more about just space in general, because there's some really cool websites that I can share with you about space, like NASA, etc. So anyway, let's talk about it. Let's answer this question before we get into the content. And if you'd like to get to the GCSE content without this, please just go to the next timestamp. Okay, so what happens if you fall into a black hole? Well, there's this idea of spaghettification, which sounds exactly as it is. So essentially, this just means if the black hole has sucked you in because of the force of gravity, essentially, you will stretch out from head to toe. And essentially, at the same time, you'd also be compressed. And this means that you would turn into a really thin noodle shape, like a spaghetti. And this is really due to the force of gravity causing that stretching, and it would mean that your head and your feet were experiencing slightly different strengths of gravity. So if you went in feet first, the force of gravity on your feet would be much stronger than on your head, and that's what gives that elongation effect, which is pretty scary but cool to think about. And then another question is, would we be able to find someone in a black hole? In theory, no, because if you think about a black hole, it absorbs all the light. So if we were to look towards a black hole, we would see complete pitch black darkness because all the light would be absorbed. However, the person inside the black hole would be able to see us looking for them, which is quite spooky in itself. And this is an idea of something called the event horizon. It's essentially like a point of no return. So as soon as you've gone into a black hole, there's really no way that light can escape. And we know that light is the fastest quantity that we know of. So being able to run out of a black hole would be there impossible. So this is what we call the event horizon. And I just thought this was pretty cool to share with you guys. So if you would like to learn more from, other scientists in that field, and maybe you're interested in careers in space, I will drop some stuff in the description box for you guys. And like I said, definitely feel free to write in the comments any key facts or questions you have, and let's get a discussion going. So, what actually are stars? They're actually made of cosmic dust and gases, specifically hydrogen. And depending on the size of the star, will depend on what happens to it in its life cycle. Now, I know the word life cycle suggests that maybe a star is living. However, we use the word life cycle because a star can change throughout its time. And these are gradual changes. These are changes that we observe quite often in different types of stars, wherever we see in the galaxy and beyond, to be honest. So, we use the phrase life cycle because there's lots of different stages depending on size. So let's have a look at some of these now. So the early stages of a star start off the same way. So the first step is the nebula. A nebula translates from Latin as a ball of gas or dust or cosmic smoke. And essentially this means that it is just made up of gas such as hydrogen and lots of dust particles. Now, that doesn't sound particularly interesting, but honestly, nebulas are one of the most beautiful creations in our universe. And I'll link some pictures below. But yeah, if you just even Google image nebulas, you'll see so many different varieties, lots of different colors. And you've probably actually seen nebulas before because often in sci-fi films, in comics, things like this, they often show nebulas when people are traveling through space because of their incredible structures. But they are just made up of gas and dust particles. Now, they form together because of the force of gravity. And over time, those nuclei of hydrogen will fuse together during fusion reactions to form a protostar. And the protostar will then start to release some heat. And over time, this fusion reaction will form into a main sequence star, which is where we are with our star, the sun, currently. So the force of gravity holding the star together is actually in balance during a main sequence star. So the forces of high pressure and temperatures are very much balanced between the two, and this causes the star to be quite stable. And this is one of the most stable phases of a star's life. So this is where our sun is currently. So, depending on the size of the star, will depend on the next stages of a star's life cycle. So, any star that is of the same size to our sun will have the next following steps. However, if we have a star that's much larger than our sun, it will have a slightly different trajectory. And I'm going to show you what that looks like in a moment. But let's look at what would happen if we had a star like our sun of this size. So, what would happen after those fusion reactions? The star itself would actually start to expand in size, and this would form what we call a red giant. Over time, then a next stage would form into a white dwarf, and this is where all nuclear reactions have completed. And essentially, what happens after that, we then form a black dwarf as well. So you can see that in these stages that the star actually starts to contract and cool down. And this is all again due to the forces of gravity. In the case of a black dwarf, it's very, very small. It's cooled much cooler than the white dwarf that it used to be. And as a result, it starts to emit no detectable light or heat. And this is the sort of thing that our sun will eventually turn into. So, like I said, depending on the size of the star will depend on the next stages of the life cycle. So, any star that's larger than the sun will follow the next few steps. The first one here is you can see we have a red supergiant, and this is due to the fusion of those hydrogen nuclei, and the star itself begins to expand much greater than what we've previously seen on the previous slide. Then essentially a supernova will occur, which is an explosion of that star, distributing those different elements across the universe, essentially to form new stars as well. And then after this, a neutron star or a black hole will form, and this depends on the mass of it. And essentially, these are just collapsed cores of massive stars that have just exploded. And this links us nicely back to the beginning of the video. Thank you for your support in watching today. I've been the GCSE science teacher and you have been curious. If you found that video helpful and you enjoyed learning about space, let me know by giving the video a thumbs up. You can also share this video with someone else and do subscribe if you haven't already. Take care and I'll catch you in the next one.